Hi everyone, in this video we're going to work a little bit with equations and graphs of circles and ellipses. So we're going to start with this. This is actually the unit circle, which we'll spend a lot of time on in trig, but right now we don't want to focus on the trig part of this, just the fact that this is a circle centered at the origin with radius 1. And we should be able to find an equation for this. Basically what you want to spot is that if you pick any old, let's see if I can put one where I can draw it, point on the outside of the circle, what's true about that point is that it's always 1 unit from the center of the circle. So x is the horizontal distance from the y-axis to our point, y is the vertical distance from the x-axis to our point, and 1 is the distance from the origin to our point. Notice this builds up a nice little right triangle. So what we can say about every single point that's on the graph of the circle is that it is, what am I trying to say? Sorry, my dogs are walking in and confusing me. What we can say about every single point on this circle is that it should satisfy the equation x squared plus y squared equals 1. So no matter where I draw this point, I can always draw in the triangle, and the hypotenuse of the triangle will always be 1. So this equation for a circle centered at the origin looks like that. So if you had a bigger circle, say the radius was 2, you'd get x squared plus y squared equals 2 squared. So kind of a general thing that's not a bad idea to keep in the back of your head is x squared plus y squared equals r squared is a more general form for the equation of a circle centered at the origin. We're really going to approach making changes to this circle by using transformation. So we won't always use this format, but it's still a handy one to have in mind. Okay, so we have this as a basis. X squared plus y squared equals 1 is a circle with radius 1 centered at the origin. And we're going to think of this as like our basic shape that we will be transforming. So first thing I want to look at, I'll mix this in with the transformation part, is why don't we write this so that y is a function of x? Throughout all of pre-calc 1, most likely you wrote everything that you could where it was y equals and then some definition involving x's. So we can try that. We get y squared equals 1 minus x squared, which means that y is equal to plus or minus the square root of 1 minus x squared. So really important first thing is if you're forgetting this plus or minus, you're in big trouble. And here's a great place to actually learn why that's such a big problem. If we're thinking functions, this actually isn't so great. Y is not a function of x, so there is a really nice definite relationship between x and y, but it's not a function relationship. We can see it in the graph. If we pick a specific x value, it's always going to get, almost always going to get paired with 2 y values, and that's what the plus minus is giving us. So I just want to point out that if we left off the plus or minus, so say, side note here, we got this y equals the square root of 1 minus x squared without the plus or minus, what we would be getting is exclusively the top half of the circle. So here we've allowed for positive or negative y values. Remember, a square root always outputs a non-negative number. So you can get 0 out of a square root, but you can't get negative numbers out unless it's a negative root. So this is only going to give me y is greater than or equal to 0. If we put the minus in front, it would give me the bottom half, and we would only get y is less than or equal to 0. So when you do this and leave off the plus or minus, what you're getting is half a circle. Okay, so into the transformations part, what do we do if we want to recenter at negative 2, 3? Here, I'm going to switch colors here so you can see on this picture. Okay, so we want the exact same, oh, I didn't even leave enough room. Negative 2, 3, somewhere way up here, we want this circle centered. So this is a pretty rough looking sketch, but that's what we're going for. So basically, we need to take this equation that we have for the unit circle centered at the origin, and we need to figure out how to shift it. So we want to go left 2 and then up 3. So if we want to go left 2, we need to make sure that we shift our x's to make them go left. We actually add 2, right? The idea being if we want to force the y value to stay the same, we would have to plug in something 2 smaller than in this original equation, which is what forces everything left 2. What can get a little weird is that since this is not written y as a function of x, when we try and shift the y's up 3, they're going to do that same sort of backwards thing. Again, the idea would be if we want to keep x's the same, we would have to plug in a y that was 3 bigger than the original equation. So that's actually a shift up 3. Notice when we moved it over here, so sort of side note here, I'm going to write it in the opposite order. Here we can see that, oh, never mind, this is the wrong one. We'll do it down here, right? This is y is a function of x. Okay, so when we do this little bit of rewriting, I'm going to say I have y minus 3 squared equals 1 minus x plus 2 squared. And then I can square root both sides. I get plus or minus the square root of 1 minus x plus 2 squared. And then I can add 3. So the final equation I get, see if this will fit. Okay, so there's the equation I get. So here, this is written, again, function. It's actually not a function, it's a relation, but we've solved for y to try and get it to look more like a function. And here we can see our typical, okay, y has to get shifted up 3. So the deal is if you move all the transformations in with the variable they're affecting, they're always going to do this backwards thing. So a plus 2 attached to your x's is going to move left 2. A minus 3 attached to your y is going to move up 3. And if you want to compare that back to what we would have done in 141, here if you move the 3 over with the y, you would have that y minus 3. So we know this is up 3. As soon as we move it with the y, it changes the sign. Okay, so we can shift a circle, that recenters it. We can also change the size of the circle. So if we want the circle to have a radius 3 and still be centered at the origin, what we need to do is stretch it. We need to stretch it both directions. So we want to do a vertical stretch by 3. The radius was originally 1. We want it to be 3. So we're tripling all of our x and y values to make that happen. In order to do horizontal stretch by 3, we actually need to make this an x divided by 3. And in order to vertically stretch by 3, again, remember, y's are going to be backwards too when we're working with this format that's not solved for y. So this is a basic idea of what that would look like. You can simplify a little if you'd like to. We have an x squared over 9 plus y squared over 9 equals 1. Because we are working on this as transformations of the basic x squared plus y squared equals 1, either one of these would be a great place. I think I like this one a little better. Great place to quit. But I will point out, I've said that you can also use that basic Pythagorean theorem setup that says x squared plus y squared equals r squared. And if you clear the fractions out of this one, it matches that perfectly. So it's not that that gives us something different. It's just a different way to look at setting up a bigger circle. Okay, and then on this one again, I say write the equation so that y is a function of x. So I'm going to go from this one so that you'll see something more like what comes up in your homework. If we say that y over 3 squared is equal to 1 minus, well, I guess I could have gone from the squared one, x over 3 squared, then we can say that y over 3 is equal to plus or minus the square root of 1 minus, and I'm going to go ahead and make that x squared over 9 again. And then we have to multiply by 3, so y equals plus or minus 3 times the square root of 1 minus x squared over 9. So again, this is how the equation for a circle will look. It looks really messy. but this is how it will look if you try and solve it for y, or if you try and solve it for x. And then by leaving off the plus or the minus, we could get just the top or the bottom half of the circle. So if you really want to double check something in your graphing calculator, you can solve it for y. You'll have to plug in 2 separate equations to get the whole thing. Okay, so what happens if we only stretch one direction? So this one, I see horizontal stretch by a factor of 4. So this thing is our basic circle centered at the origin, but now it's stretched horizontally by a factor of 4. So instead of going through 0, 1, it will go through 0, 4. And instead of going through 0, negative 1, it will go through 0, negative 4. We haven't stretched it vertically, so it still goes from negative 1 to 1. So when we connect the dots here, we stretch it out. Oh, that's looking really wobbly. So excuse the fact that mine is a little ugly. What we get is an ellipse. So there's some really cool geometric properties of ellipses. We're not going to get into that at all. I just want you to recognize the basic structure of an equation for an ellipse or a circle. They do come up on occasion. The circle in particular we'll work with a lot this quarter, but both circle and ellipse can sneak up on you in calculus. So if you think about it as taking the circle and stretching it only one way, or stretching it more one way than you do the other way, or compressing it more one way than the other way, anything like that, anything where you have horizontal stretch or compression and vertical stretch or compression and they're not exactly the same amount, you'll get an ellipse from. All right, thanks for watching.